An unprecedented event quietly unfolded, shaking the tranquility of the global astronomical network. An ordinary entry in the Minor Planets Enter MPC Planetary Defense System to make an unprecedented adjustment to its monitoring equipment. This was not due to an imminent threat to Earth, but rather an inexplicable phenomenon. The activity of an object known as 3I Atlas completely defied existing scientific understanding. The Minor Planets Center MPC, affiliated with the Harvard-Smithsonian Center for Astrophysics, serves as the official register and verification authority for newly discovered asteroids, comets, and interstellar visitors worldwide. It aggregates observational data from thousands of telescopes, regularly publishing the Technical Minor Planet Electronic Circulars MPC. These circulars typically contain routine matters, orbital updates, brightness measurements, or minor corrections, yet the quietly released notice for 2025 U-142 in late October 2025 contained an unexpected annotation. This annotation was concise yet startling. Astronomical Survey Mission IVUN, November 27, 2025 to January 27, 2026, target, Sheevish, 3-star charts. These few words heralded the beginning of a historic astronomical event. The International Varying Object Network IVUN, a cornerstone of the global planetary defense system, was fully activated for the first time due to an interstellar comet. This network pools resources from NASA, ESA, JIXA, and numerous observatories worldwide to establish a unified rapid response mechanism. Established after the 2013 Chelyabinsk meteor explosion in Russia, IVUN ensures no nation faces an impact threat alone. When activated, telescopes worldwide synchronously track a single target, rigorously verifying its behavior. Typically, IVUN focuses on Earth-impacting objects. However, the network had never before dedicated such extensive global resources to monitoring a comet, let alone an interstellar one. This unprecedented activation suggests that the object, named 3I Atlas, exhibits behavior beyond conventional physical laws. Officially designated SEED E2025 NUN-3I Atlas, the system was first observed on July 1, 2025, in Chile by a robotic composite system designed to search for near-Earth asteroids. Initially mistaken for a long-period comet, it was later identified as an interstellar visitor. It was first observed on July 1, 2025, in Chile by a robotic composite system designed to search for near-Earth asteroids. Initially mistaken for a long-period comet, orbital analysis days later revealed its eccentricity exceeded 1. This indicates it is not gravitationally bound to the Sun but originates from another star system. This marks the third interstellar object confirmed by humanity, following UAMUA in 2017 and comet Borisov in 2019. Spectral analysis indicates 3I Atlas contains typical cometary gases, cyanide and carbon diatomic molecules. Yet puzzling lie, these gases exhibit temperatures far higher than expected for its distance from the Sun. Its unusually rapid rotation and exceptionally bright surface may suggest a metallic composition, estimated to be between 5 and 10 kilometers in diameter. It is smaller than comet Borisov but larger than UAMUA. Shortly thereafter, 3I Atlas's orbit began exhibiting significant deviations. A systematic and persistent discrepancy emerged between its observed light center position and its predicted trajectory. The stability of this deviation ruled out measurement errors. While active cometary outflows can occasionally cause slight light center shifts, 3I Atlas's deviation spanned hundreds of kilometers and remained unusually stable. This phenomenon was confirmed by multiple leading observatories, including Paranal, Mauna Kea, Cerro Tololo, and Los Campones. It clearly indicated that 3I Atlas was experiencing a powerful non-minus gravitational acceleration pressure or gas outflow could explain. Furthermore, its brightness fluctuations lacked symmetry and showed no predictable periodic thermal cycles. All this data fundamentally challenges existing astrophysical models. It was at this critical juncture that IVUN fully intervened. IVUN immediately launched a large scale photometric survey, effectively applying planetary defense theory to study a real interstellar object. Every major telescope received unified, synchronized instructions, including identical exposure parameters, filters, and stellar reference points. Each image's coordinates were precisely cross-referenced against Gaia's stellar catalog to eliminate systematic errors, then immediately transmitted to the Minor Planet Center for real-time processing. This marked the largest and most precise tracking operation in astronomical history. Observatories in Hawaii, Chile, Spain, South Africa, and Australia operated in around the clock relay, seamlessly switching between hemispheres to continuously monitor 3I Atlas's trajectory. Trigonometry, the art of pinpointing celestial positions to arc milliseconds, became crucial for precisely predicting its trajectory. If the observed light point persistently deviated from a purely gravitational path, it signaled an unknown force beyond the Sun's gravity was at work. Each data update is processed by the MPC before being transmitted to NASA's Jet Propulsion Laboratory, and DSA's near-Earth objections undergo hourly precision calibration. This operation is far more than tracking a comet. It represents a comprehensive stress test of humanity's planetary defense system, designed to evaluate our response capabilities against unknown threats. November 10, 2025. Observatory Technical Briefing. November 25, 2025. System testing completed. November 27, 2025. January 27, 2026. Primary observation window opens, covering critical periods when the comet reaches its farthest point from the Sun and its closest approach to Earth. February 3, 2026. Data review meeting convened. During this 60-day intensive observation period, 3I Atlas reached its maximum brightness at a distance of just 0.82 astronomical units from the Sun within Earth's orbit. Continuous monitoring enabled scientists to map every deviation from its predicted trajectory in real time. If 3I Atlas behaves like a typical comet, it will validate the accuracy of our tracking algorithms. Conversely, it may reveal entirely new physical laws or undiscovered technological principles. We know comets brighten as they approach the Sun due to ice evaporation, yet 3I Atlas exhibits an irregular luminous pattern, strongly suggesting an internal energy source. Even more puzzling, its rotation and temperature fluctuations exhibit characteristics that appear deliberately engineered, as if driven by controlled propulsion rather than random ice evaporation. The activation of IVUN and its subsequent propulsion only rapidly made headlines after amateur astronomers also noted the same anomalies. Yet the tone within the network remained unusually grave. Each data update revealed 3I and it duos by precisely the same margin, as if guided by an invisible force. NASA's official statement cautiously noted they were investigating this non-gravitational acceleration phenomenon. Yet in informal settings, insiders revealed researchers had begun comparing 3I Atlas's motion to a mountain-sized solar sail currently undergoing testing. Additionally, IVUN seized this opportunity to conduct a live drill of its asteroid deflection protocol. Coordinating hundreds of observatories to achieve perfect synchronization is a skill that will prove vital should an actual impact threat ever materialize. In this sense, 3I Atlas provided the world with invaluable experience, a living, unpredictable target to test and refine our planetary defense systems. Yet a deeper question lingered in many minds. Why did this interstellar comet behave so much like a controllable spacecraft? As Comet 3I Atlas neared Purulhana, its brightness flickered erratically, yet its tail showed none of the typical gas jets. Instead, spectrometers detected a slender ion trail, charged plasma ejected at fixed intervals, each emission precisely synchronized with the comet's 9-hour rotation cycle, a regularity reminiscent of pulses from an engine array. More eerily, radar measurements revealed a metallic reflectivity spectrum, strongly suggesting a smooth surface, perhaps even artificial. By late January, the global observational dataset was fully compiled. The Minor Planet Center synthesized millions of data points to construct the most detailed orbital model ever for an interstellar object. The final conclusion was startling. 3I Atlas had undergone multiple accelerations and decelerations in space, phenomena unexplainable by any known natural force. When this story leaked, social media erupted. Podcasts and late-night shows drew parallels between 3I Atlas and MUA, labeling it an interstellar spacecraft. Conspiracy forums went further, claiming NASA was covering up evidence of extraterrestrial contact. In truth, scientists were equally perplexed, but adopted a more cautious stance. NASA's official position stated, 3I Atlas remains under close monitoring, and existing models cannot explain all its orbital movements. In informal settings, insiders admitted they'd never seen a celestial body like this. Interstellar objects are supposed to pass through swiftly, never to return. Yet 3I Atlas forced the entire planetary defense system to operate in concert for the first time in history. For the Minor Planet Center, this proved its system could swiftly shift from routine observation control within hours. For IVUN, it demonstrated humanity's capability to track unpredictable objects, yet also revealed an unsettling possibility. One day, we might have to track an intelligent object. By early 2026, Comet 3I Atlas had receded far from Earth's orbit, heading back into the cold depths of deep space. The final report described its orbit as hyperbolic, with an unstable brightness curve exhibiting non-periodic variations and a trend toward accelerating evolution toward non-gravitational properties. The project was officially declared a success. Yet, informally, many astronomers remained convinced after the project's conclusion that 3I Atlas was not just another transient. For if a natural celestial body could move, pause, restart, and defy gravitational laws in such a manner, our understanding of celestial mechanics was clearly far from complete. Today, the name 3I Atlas rests quietly in the database of the Minor Planet Center, just one string of code among millions. Yet behind this single line lies the story of the first activation of Earth's planetary defense system, not to stop a threat, but to understand it. Perhaps 3I Atlas is merely a comet exhibiting anomalous behavior, or perhaps it is something entirely different, a silent messenger drifting through the cosmos, reminding us how little we truly know about the mysteries hidden in the depths of the universe. This is no longer just astronomy, it marks the beginning of a new chapter in how Earth perceives the cosmos.